Okay, good evening, ladies and gentlemen, and welcome to this day one of Lean Six Sigma Black Belt Certification Hackathon. Now, tell me how many of you in the room right now are already Green Belt certified? Just type me in the chat box. If you are already Green Belt certified, just type me in the chat box. Everybody, let me see. Okay, okay. Wow, a lot of people are Green Belt certified, huh? Amazing. Okay, just a second. Let me just do a setting here. And yes, just a second. Give me Anji. Okay. Chaliye, so fantastic. So this hackathon, let me just give you a quick background about what is hackathon and why we have started it. See what used to happen after our yellow belt session, no? Yeah, just a second. Let me just come back again. Huh. So after our yellow belt session, what used to happen? Uh, People used to get busy in their life, and of course they used to connect on the live sessions, but certification examination they used to postpone. Okay, so we started to take some some initiative so that the people will be pushed, and it will be a summary as well. They will enjoy the session as well, and at the end of the session they can give the exam and get themselves certified. Okay, so it's kind of a gentle push towards the to cross the boundary line. Okay, so this entire hackathon was started like that. That's why we connect every month, 3 days consecutively, just to make sure that we summarize the entire topics, the main topics basically, the important topics which require some clarity, some practice, etc. And those topics we cover in the hackathon. Okay, so super. Let me just okay. Chaliye. So are you guys ready? Have you taken the pen, paper, notes? So we'll start lot of practices with Minitab in this black belt session. Okay. So if you have Minitab with you, just open a fresh Minitab worksheet, Okay, we'll start with something very interesting. Okay, once you have opened it, let me know in the chat box that I have opened the blank fresh Minitab worksheet. Now, the people who are very new but still they are attending this, if you don't have Minitab, if you are not gone through this green belt, etc., absolutely okay. Just go through this process. Anyways, this will be this will make sense when you will basically go to the black belt. Okay, चलिए हो गया. Everybody just give me opened in the chat box so that I can basically check out and proceed further. Yes, thank you, Amruta ji. Thank you very much for the confirmation. Who else? Okay, thank you, Ritesh ji. Fresh open kariye, blank worksheet open kariye, and just type opened in the chat box. Okay. Very nice. Chaliye. I hope everybody's following. If you don't have laptop or you don't have or you're traveling, you are not in a position, just observe what we are doing and that will be good enough. Okay. हाँ जी, तो अभी क्या करना है? Let's understand this. Now we will generate the data in Minitab. So first what we'll do, go to calc. There is a third option called fourth option, file, edit data and calc. Calc meaning calculator, random data and normal. Just follow this path. Calc, random data, normal. Just follow this path quickly. Calc, random data and normal. Yes. Once click on that, this window will appear. What we'll do is we will generate 5 data points. So number of rows of data to generate, just put 5 and store in the column C1, column number 1 में store करेंगे, and just click OK. Don't do anything else. Just click OK. So some 5 random data will get generated. Okay, so go to calc, random data, normal. Okay, just put 5 here, 5 number of rows. Store data in column C1 and just click OK. So 5 random data, we are not putting any inputs there. Done. All right. Everybody just type done in the chat box. 5 data आ चुके हैं. Very nice. So that way you can see यहाँ पे आप mean and standard deviation भी दे सकते हैं. For example, let's say I go back. So I can put mean, let's say 50. I'm just giving you example. Mean 50, standard deviation 1. Okay, there are two options available, mean and standard deviation. So here we haven't given any option, but you can give the option and standard deviation will be basically shown. Okay, so let's do away with this. Now let's make a histogram out of it. Let's go to graph and make a histogram. Okay, go to graph and you will find the 5th option, histogram, from the top. Just click on histogram and just find with fit. So first one is simple. Second one is with fit. Just select with fit. Say OK. Select the column number 1 where the data is there and say OK. Yes. Now everybody's data will be different. So histogram will be different. Have you got this kind of histogram? Just type yes in the chat box, everybody. Yes, everybody got this? Just type yes in the chat box. Very good. Super. So we don't need any data. Without data also, we can create certain kinds of histograms. Correct? Very nice. Chalo, let's go back to the data. Now, the same process we will follow and we will generate 50 data points now. 50. Okay? Let's go to calc, random data, normal. Now, instead of 5, we will generate 50 data points in the column C2. In the column C2. So in the second column, we will now we'll bring 50 data points now. We'll generate 50 data points. Just click on OK. And now the software has created 50 data points, random data points for us. Again, your data and my data is different. So doesn't matter. Just follow this process. And the same process, let's do this for C3. Now we will generate 5 or let's say 5,000 data points. Let's put 5,000 over there and put C3 and click on OK. So you've got 5,000 data points in the column number 3. You can see here. Everybody got it? Just type yes in the chat box. So in the first column, we have got 5 points. Second column, 50 points. The third column, 5,000 data points. Now we will do the same process for C2 and C3, the histogram. Okay. So let's bring histogram now. Go to graph, histogram. Go to fit. Okay. Now instead of C1, just select C2. Now do the same thing for the C3 as well. Go to graph, histogram. Select with fit, C3. So let me bring all the 3 data points. So let me just put all the 3 data points besides each other, okay? So that we guys can check that out. Everybody got it, by the way? Just type yes in the chat box. थोड़ा और छोटा करते हैं इसको. Wow, fantastic. Everybody got it? Just type yes. Amazing, amazing. Now you can see here, What is your observation of all the three histograms are in front of you? So this is histogram of 5 data points. Is it normal distribution? This one? Yes or no? 5 data points. Is it normal distribution? Everybody? Yes, no, yes, no. No, does not seem like, right? It is not normal distribution because it seems to be a skewed distribution. Okay. Now, what about this? This is 50 data points. Is it normal distribution? Everybody? Just give me yes, no in the chat box. Is it normal distribution? Ha, na? Not exactly. Yes, it looks like, but not exactly. But at least we can say fair enough. But what about this? The third one, where we have 5,000 data points. Is it normal distribution? Yes, absolutely yes. Very much symmetrical. It's kind of very perfect normal distribution. Yes or no? So what is the observation here? What have you observed? What is your observation? Type in the chat box. What is the observation? Require more data points. Okay. What else? बोलिए बोलिए. Okay, let me just हाँ जी. So I think you guys can check each other's points as well. So more data points, normal distribution. All line items need data, not zero. The large number of data is more normal distribution. Very good. Sample size increases the data prediction more easy. Very good. Fantastic. So that means more the data. Now try to understand this. If we are taking the data from the same population, more and more data is drawn. Okay, the distribution automatically takes the normal distribution. Are you understanding? So if you have less amount of data, you may not get normal distribution. But the moment you increase the sample size beyond 50, 100, 500, 5,000, naturally you will get the normal distribution curve. Okay, the point is that why 5 points are not normal, because they are random data points. And this theorem is called as, write this down, central limit theorem. Central limit theorem, write this down. So the central limit theorem says, as your data points go beyond 30, 50, 100 above, then you will see a normal distribution tendency of the data set. Clear, everybody? This is called central limit theorem. Everybody just type CLT in the chat box. CLT. And why normal distribution is required? Because normal distribution is a predictable distribution. Yes or no? For example, imagine, let's say if I put specification limits here. Okay. Let's say specification limits here and here. This is lower specification and upper specification. Okay. On one side, there will be more. On one side, there will be less amount of defects. But when it comes to the normal distribution, it can be symmetrical so that we can check the defect region perfectly symmetrically and we can predict the process capability properly. So the prediction about the population behavior becomes very predictable when it is normal distribution. Are you clear with this? Just type yes in the chat box. ये समझ में आया फंडा? Why we need normal distribution? Because then we can predict about the behavior of the population. very nicely. So stability and normality are very, very important characteristic of the data to predict the behavior of the population. Clear? Just type yes in the chat box. So what have we learned here? We have learned how to generate the data in Minitab and how to create multiple Minitabs and what is central limit here. Clear? Just type yes. समझ में आया? Very good. Now let's do one thing. Let's go to C2 and we will do something called graphical summary. Okay. Stat, basic statistics, graphical summary. Just click on graphical summary. And C1 का नहीं लेते हैं because C1 is very 5 random data points are there. Let's take C2 or C3. Let's take C2 and click on OK. I repeat again. Go to stat, basic statistics, graphical summary. The third one, the third option. Stat, basic statistics, graphical summary. Okay, once you click on that, just select C2 because C2 has got 50 data points and it is fairly normal distribution and say OK. So you will get similar kind of display. Everybody got this display? Just type yes in the chat box. You can take C3 as well. C3 भी आप ले सकते हो. Clear? Clear है? Got it, everybody? Now? Chalo, now you are going to become black belt. So you tell me what are these? So what is this graph called as? Everybody type in the chat box. ये graph को क्या कहते हैं? We have just plotted. Yes, what is that? Histogram. Exactly. It is called histogram. Okay. There are two words here, histo and gram. Gram meaning graph and histo meaning historical data. So historical meaning the past data. Whatever data, the sample data we have created, we have collected, we have created a graph out of it to check the distribution of that. It's called histogram. And bell-shaped curve is this red line. Okay, this red curve, which is basically, it is called bell-shaped curve. Okay, it looks like a bell, correct? So now what is this graph called as, everybody? What is this graph called as? Yes, this curve is the bell-shaped curve. Exactly, Anushka. You are absolutely right. This is called box plot. Everybody knows box plot. All the black belt people, yes or no? This is the same depiction of the distribution. Now, for example, this is the lowest value in the box plot. This is quartile 1, if you remember. This is quartile 2 or median, the same thing. And this is quartile 3. And this point is where the data ends, but you have I'll just remove this so that you can check this out. You can see there is one outlier here. Can you see here? In my graph, there is one outlier because there is one data point which is going beyond this length. Okay, that's why it's called outlier. Anyway, but this is called box plot. Everybody knows box plot, right? Correct? Very good. Now, what is this Anderson-Darling normality test? What does it do basically? Type in the chat box. Green belt में सीखा है हम लोगों ने. बोलो, what is Anderson-Darling normality test do? नाम में ही सब कुछ है. हाँ जी, fantastic. Yes, what does it do basically? Type in the chat box. Absolutely right. Raish ji, you're absolutely right. Correct. Sanchari ji, absolutely right. So it checks basically whether the data is normally distributed. See, when we drew the histograms, I asked the question, is it normally distributed? So you were saying, yes, it is, but not sure. Okay, looks like normal distributed. But here, with this Anderson-Darling normality test, we can confirm this. If the p-value is greater than 0.05, then the data is normally distributed. Make a note of this. If the data is, if the p-value is greater than 0.05, then this is called a normal distribution. Okay. And tomorrow I will show you how to basically calculate the p-value manually as well. हम लोग manually भी calculate करेंगे. ठीक है? कल हम लोग advanced hypothesis testing करेंगे, in which ANOVA, chi-square test, and pair t-test, all those advanced tests will do, F ratio test, etc. Where we will basically do this. Okay. So after that, everybody's clear about mean, standard deviation, variance, skewness, kurtosis, n is equal to number of data points, 50. What is the minimum value? What is the first quartile, second quartile, third quartile, maximum value? All these data points are there. And this entire data set is called as descriptive statistics. And this one below this is called inferential statistics. Make a note of this. Inferential statistics. Now, the new people, it might sound a little different or difficult because you have not yet heard about this. Okay. But as you go through the Greenbelt curriculum, Greenbelt hackathon, and our live sessions regularly, all these data, all these terminology you will hear again and again, and it will basically, it will become very easy. Clear, everybody? Super. So this is called as inferential statistics. What is inferential statistics? Inferential statistics is all about the, what you can say about the population. This is a sample of 50 data points. So according to sample, let's say, for example, let me just remove all this. So let's say the mean of this sample is this, right? Minus 0.07155. This is the mean of the sample here. Okay. So if the mean of the sample is here, what will be the mean of the where will be the mean of the population? So with 95% confidence, we can say that the mean of the population is between minus 0.34 to 0.20. And this is the formula associated for the calculation. Okay. And I have taken confidence interval ka session also in the past. So you can check that in the masterclass archive, how the confidence intervals are calculated manually. Okay. Same goes with the median. Now median is this. If this is the median for the sample, then what will be the median of the population? It will lie between, with 95% confidence, it will lie between minus 0.46 to 0.23. And same with standard deviation. And this is called as 95% confidence interval or inferential statistics. We are predicting if this is the sample behavior, then what will be the behavior of the population. Clear, everybody? Just give me yes in the chat box. Clear hai? Super clear. Now, whenever the data is, now understand this. Whenever data is normally distributed, okay, go for mean. If the data is non-normal, go for median. Remember this, make a note of this. Whenever the data is normally distributed, you can use the mean as your central tendency. But whenever there is a skewed distributed data, okay, you can basically check the median of the data and not the mean of the data. Clear? Just make a note of this. Everybody clear till now? Just give me yes. Any doubt? So what we have seen how to generate data in Minitab, how to create histograms, what is central limit theorem, what is descriptive statistics, inferential statistics. All right, super. See here in the black belt curriculum, we are not going for the topics which are already covered in the green belt hackathon and green belt curriculum. Okay, so green belt के topic हम लोग यहाँ पे cover नहीं करते हैं. We are only covering exclusive black belt content, that too which requires a little bit of explanation. Okay, skewness line क्या है? Which skewness? अच्छा, skewness. See, skewness and kurtosis meaning. Now, for example, there are two types of skewness. Now, if you have data like this, I'll give you example, practical. Skewness का practical example बताता हूं मैं. Let's say you go to office and there is your biometric system which gets the thumb impression and which checks your attendance. Yes? Okay. Now, whenever the biometric system is working and if you collect the data of people's office arrival, understand this. So generally it will look like this, a normal distributed data when there is a biometric system happening. Let's say this is 9 o'clock. So most of the people will come around 9 o'clock here. Some of them will be early, some of them will be later, but most of them will be around 9 o'clock. Okay, when your biometric system is working. Now, what happens is, one fine day, your biometric system basically fails. Okay, the moment your biometric system fails, what will happen? People will start coming a little late. They will take advantage of the situation and the distribution will look like this, where 9 o'clock is here, but majority of the people will come here. Everybody with me till now? This is 9 o'clock because there is no biometric, there is no tracking of the timing right now. Clear है? समझ में आ गया है ये system? And this is called left skewed distribution, left hand side, or negative skewed, or left hand skewed, LHS, left hand skewed. Everybody, if the tail of the distribution which is extended on the left hand side, it is called left hand side skewed. Let's take another example. Now your management understands this. Now what management says that anybody who comes early, 10 to 15 minutes early, they will get some benefit. They will get some reward and recognition. The moment management announces that, then people will start coming a little early, and now you will get this kind of distribution. It is called positive skewed distribution, or RSS, which is right hand skewed, where this is 9 o'clock, but because of the reward and recognition, people will come early. Are you getting this? Both this scenario? Just give me yes in the chat box. Very simple, logical, mundane scenario, everyday scenario. Clear? Okay, so this is called the skewness. So either you have to be normally distributed. So this is normal. This is right hand side skewed, and this is left hand side skewed. So even normal also, we will never get 100% normal. So there is a small skewness is there, and this skewness is measured here. This is called that skewness, 0.022. It's very it's very negligible, 0.022. It's a small tilt towards the right hand side. Okay, so this is called, you can see here a small tilt at the right hand side. You can see very small tilt. Okay, this is called skewness. Clear, everybody? Just type yes in the chat box. Clear hai? Superb. Now, so once we, in the see, define phase basically for the green belt, yellow belt, and the black belt remain similar. Okay, there will not be any change, in the define phase. In the define phase, what are the tools do we cover? Project Charter, SIPOC, stakeholder analysis, communication plan, Racimetrics, right? So these are 5 to 6 tools we use. Everybody, correct? this project charter, SIPOC, stakeholder management, Ratiometric communication plan. So these are 5 to 6 tools which are common in green belt and black belt. So I'm not covering that again here. Okay, we are directly covering the major part, which requires some statistics and Minitab. Okay, yeah, kurtosis basically is measurement of the pickedness, basically pickedness. How how picked data is. Pickedness meaning, let's say this is a flatter distribution. This is a little picked distribution. This is more picket distribution. Okay. So this is how this kurtosis basically shows. So there is a formula to measure kurtosis. So this basically shows how data is picked. Okay. Yeah. So this is about it. Now the next part is called as measurement system analysis, MSA. Okay. So let's do one thing. Go back to the data once again. Go back to the data file. Now, everybody knows MSA, right? Measurement system analysis. Just give me yes or no in the chat box. MSA. We have covered that in our Can I just scroll it down, please? I'm not able to see this. Haji. So MSA is measurement system analysis, which basically is the data which we, whatever data we collect. So we use certain mechanism to collect the data, right? We use certain equipments to collect the data. So measurement system includes man plus equipment, correct? So what statistics say, the total variation which is coming from the process, some can be from the measurement system as well. Okay, so if this is the total variation coming, so this variation can be from a measurement system. Measurement system, okay? And to find out, to basically quantify how much variation is induced because of the measurement system, we do measurement system analysis, MSA. Okay, Haji. So the variation from the process. So if measurement system variation is 10%, acceptable. 10% is a good measurement system. Up to 30% we can accept, but beyond 30% we have to reject measurement system. Okay. So generally what happens is there are two parts of it. If you have continuous data, we use gauge R and R. And if you have discrete data, we use attribute agreement analysis. Everybody use this? Yeah, Nitesh ji, we haven't shared any file yet. अभी तक फाइल शेयर ही नहीं की है. ये तो हम लोगों ने डेटा जनरेट किया है अभी. Okay, we'll generate it. I'll share the file now. After 10 minutes, I will share the file. Okay. So if you have continuous data, we'll do gauge R and R. And if you have discrete data, we do attribute agreement analysis. So we will go deeper into this today. Okay. Now in gauge R and R stands for repeatability. And second R stands for reproducibility. Write this down. The basics we already covered in the green belt. I'm just revising the same thing. So what is repeatability? Repeatability meaning the same sample. If you take the same sample plus the same equipment meaning the measurement equipment, okay? Vernier caliper, screw gauge or speedometer, pressure gauge, whatever equipment you're using. Same equipment plus same person. If, let's say, for example, if I want to measure the diameter of this pen, okay, this is the pen I'm writing with, and I want to measure the diameter. and have a screw gauge or vernier caliper with me. So the same sample, the same vernier caliper, and I'm the same person. If I'm doing multiple readings, if the readings are repeating, that is called as repeatability. Ability to repeat the reading is called repeatability. Ability of the person to repeat the same reading again and again is called repeatability. Then the second one is called reproducibility. What is reproducibility? Reproducibility meaning the same sample plus the same equipment, but at this point time, it is different person. Okay. Now the same pen will be given to another person if that person also is producing the same result as what I had produced earlier. That is called reproducibility. Ability to reproduce the same result by the different people is called reproducibility. Clear hai? So repeatability basically it's called as EV or equipment variation, and reproducibility is called as AV or appraisal variation. Make a note of this. And all of these are basically coming from the guideline of AIAG. Okay. Guideline of AIAG. What is AIAG? It is a basically a automotive group, global group, which is called Automotive Industry Action Group. Automotive Industry Action Group. Okay. And what are their norms? They suggest that take 10 samples, take minimum 10 samples, and take, three people or three appraisals, and every appraiser will take 3 readings of each and every sample. Okay. So if you multiply, it will be total 90 readings minimum they are expecting from us. Okay. 10 into 10 into 10 to 3 into 3, it's called 90. So AIG guideline says take 10 samples, take 3 people. Why 3 people? Generally, we have, let's say, shift operations, A shift, B shift, 3 shifts. So there are generally 3 people associated with this. So take them on board, and for every reading, take repeat 3 readings. Okay, so similarly, you will get 90 data points, and then we will go for the analysis. And this is the basic stuff. We have covered this in the green belt as well. Everybody's clear? Just take a screenshot if you just give me yes in the chat box. समझ में क्या गया? Yes, yes, yes. हाँ, EV is equipment variation and AV is appraiser variation. So repeatability का जो number आएगा, that is basically is because of the equipment variation. Whatever variation is coming, because the person is same, so whatever variation is coming, that is coming from the equipment. Are you understanding? Now, when it comes to reproducibility, because there are multiple people associated, okay, so whatever variation is coming, that is because of the different people, and people are called appraisers, right? It's called appraisals variation, AV. EV is equipment variation and AV is appraiser variation. Clear? Everybody clear till now? We'll do a practical. First, we'll create a worksheet, how to create the data collection worksheet of the gauge R&R. Okay. Then we analyze the gauge R&R. Then we'll go to attribute agreement analysis. ठीक है? ले लिया स्क्रीनशॉट इसका? Very good. Now let me just share a file with you guys. Okay, so I've just shared a file of GRR. ओके नहीं नहीं, एक मिनट, जस्ट जस्ट होल्ड ऑन, जस्ट उसको डाउनलोड मत करो। फर्स्ट हम लोग क्रिएट करेंगे वर्कशीट। फर्स्ट आई विल शो यू हाउ टू क्रिएट अ वर्कशीट एंड देन विल ओपन द फाइल। ओके, विल ओपन द वर्कशीट एंड देन वी विल ओपन द फाइल। अभी फाइल मत ओपन करिए, बाद में ओपन करिए, ठीक है। इसको मैं हटा देता हूं। लेट मी रिमूव दिस। नाउ व्हाट विल डू इज we'll create a worksheet first. So how to create a worksheet? Go to stat, go to quality tools, get study, create GRR study worksheet. Everybody just follow this path. Stat, quality tools, get study, GRR worksheet. Then we will go for that analysis of the worksheet. अभी आप डाउनलोड करके रखिए, but we are just creating it first. ठीक है जी। Once you have done it, just type done it yes in the chat box. Okay, so done everybody. I just repeat again. Stat, quality tools, get study, create GRR study worksheet. Okay, the people who are doing along with us, along with me, just give me the confirmation in the chat so that I will just move ahead slowly. Once you click on that, this will appear. Correct? Okay, now let's look at this. So number of parts are 10, and as per the norms, we need 10 parts. Okay, number of operators 3, of course. So let's write the name of the operator. Let's say, let's write Amar Akbar Anthony. Okay, चलो, तो एक है अमर, एक है अकबर और तीसरा है एंथनी। Alright, so we have got Amar Akbar Anthony as our operators or appraisers. Okay, and number of replicates. So here, yeah. So here is the number of parts, which are 10. Number of operators or appraisers are 3, and we have given the names. And number of replicates, here we need, instead of 2, we require how many replicates? How many replicates, guys? Type in the chat box. Replicates meaning, yes, the repeat readings. Okay, so we need 3 readings, right? So 3 we will select, right? Very good. Option में क्या है? हाँ जी, just go to option. Just go to option. And actually, if you click on option, it will say that randomize runs within operators. Randomize करो operators के run. ऐसे वो बोलेगा. Okay. So just keep it as it is. Just say okay. And just say okay. And there will be a worksheet which will get created. Now, look at this. So Amar will take part number 2. Okay, everybody got it? First of all, tell me. Type in the chat box. Got it? Fantastic. So this is the worksheet you need to follow. Now take the same equipment, take the reading. Let's say take the part 2, give it to Amar and ask the reading. Let's say Amar says 10.3. Then give part number 10 to Amar. Amar does not know which part is what. Amar does not know part ka number kya hai. Understand this? If he knows, then a bias will creep in. He will remember that, okay, 10.3 the last time, so he will write 10.3. So he should never understand what is the number. Okay, so that has to be randomly given, and a person who is conducting this only should know what is the actual number of the of that part, basically. Okay, it may be a diameter or the length or the width or the weight, whatever it is. Okay, then uska 10.2. Then again the third part will be given to Amar. Let's say 10.0, etc. And then we will take the reading. Then Akbar will take the reading, Anthony will take the reading, again Amar will take, and this will continue for the 90 data points. Are you clear, everybody? This is how we have to collect the data. Once the data is collected, then we go for the analysis of the data. Super clear, everybody? Just type yes in the chat box. ओके इसमें एक आपको एक इंपॉर्टेंट बात बताता हूं. लेट्स से इफ यू वांट टू टेक दिस डेटा एंड make a printout of this, okay, and if you want to give it to multiple people, let's say for example, okay, so understand this. What we need to do is, if you want a standard order, okay, just go back to the edit last dialog box, which is Control E. Just press Control E. I'll show you a technique here. Go to option. Now, whenever we say randomize runs within operators, right? Everybody, randomize runs within operator. So, if you just put base of random data generated, just put 1, 2, 3. Everybody just put 1, 2, 3. I'm just doing one experiment here. In the randomize runs with operator, जहां पे है ना base for random data generated, just put 1, 2, 3, a random number. Okay, and say okay. And say okay. Okay, go back to the data. Now, the order has changed, but if you put 1, 2, 3, okay, the order on my screen and your screen will be matching. 6, 1, 7, 4, 9, 5, 8, 10. If you have exactly followed what I've done. How many of you got the same order? Just type me in the chat box. Got the same order? Okay, Raish ji has got the same order. All right. What does it mean? So if you want to generate a common, so now when we put a common number, common base number, so the software will take the same order. So algorithm में वो number के साथ एक order associated है. So everybody will get the same order. Clear? So whenever you want to make multiple, what you can say, printouts of this, you just put a random order generator, same number, and everybody can generate the same order in their laptop. Okay? Super. Yeah, got the same order. Fantastic. Now you can open that file which I just shared to you. Okay? मैं फिर से एक बार share करता हूं. Gauge R&R. Now this is a different file with some data associated, data included into this. Okay? डाउनलोड कर लीजिए इस फाइल को. मीनवाइल मैं भी ओपन करता हूं फाइल मेरे लैपटॉप में. ओके, yeah, once you have downloaded that, just click on open and just type open in the chat box. Super. Everybody got this file? So similar to, आपको फाइल नहीं मिला? हाँ, पारस जी, do you have Minitab downloaded there? You have to have Minitab downloaded on your laptop. ये मोबाइल पे नहीं ओपन होगा. फर्स्ट ऑफ ऑल, this will open on the laptop or the desktop where the Minitab is installed. Minitab software होना चाहिए. Okay, so I'm giving you the same file in the chat. Okay, now let me check. डन. विजय, योगेश, मनीष वाला फाइल. ओके, जिनके पास नहीं है, ओके ओके, नाउ लिसन टू मी वेरी केयरफुली. जिनके पास नहीं है, go to your course content of the black belt. ओके, जिनके पास नहीं है, गो टू कोर्स नंबर 2, go to course number 2, which is Lean Six Sigma Black Belt certification. All right, just open that course, go to LMS system, open that course, and in the course just scroll down to the section called measurement system analysis black belt. ये वाले सेक्शन में आपको आना है. The people who are not receiving the file in the in this chat, okay, go to your black belt curriculum and go to your this one, okay, measurement system analysis. Now in this you have got GRR Minitab exercise. इस पे आप start पे click करिए, click on start, and then okay, on the left hand side whatever file is there na, just click on that, it will get downloaded. Got it everybody? Provided you have Minitab installed. Got it? Just type yes in the chat box. तो आप ये कर दीजिए फटाफट. Go to black belt, go to MSA measurement system analysis black belt. ठीक है? In that GRR Minitab exercise पे start पे click करिए. On the left hand side you will find a file. Clear? Just type see in the chat box. हाँ जी, yes. So that's what basically a lot of people suggested that can we get, see now understand this. We have got it. The people who were not able to do this, you can use this path. Okay. Now, before we go to GRR, everybody is aware about the 40% referral bonus scheme, right? Just a little digression I'm doing, but this is important. Everybody's, yes, just type yes in the chat box. Are you aware of the 40% referral bonus scheme, which is going to be closed now very shortly? So what we have done, okay, because now we have got 2 live sessions, Monday and Saturday. We have got hackathons. We have got yellow belt session on Sunday. So you can basically enroll anybody to these live sessions so that they will understand how deeply we go inside the topic. Okay, how practically we exercise the, the topics, we understand the topic, we discuss the topics, etc. So for you, for them, the decision becomes very easy. Clear hai? So I would highly recommend, you can recommend the yellow अपना YouTube का channel का link, वहां पे भी उसके recordings है अभी. Okay, so उनको वो दिखा सकते हो आप and let them take the decision about it. Clear? So that will make your life easy to explain them what is Lean Six Sigma and how we learn Lean Six Sigma. What is our unique way of learning Lean Six Sigma? Clear everybody? Just give me yes in the chat box. And before that offer gets closed, please make the maximum out of it. Okay. Very good. Very good. Super. Chaliye. So let's open that file once again. Minitab exercise ka file. Vijay, Yogesh. Okay. Now we are going to do. So first we have created a worksheet. Now we have collected the data. Now we will analyze it. So how do we analyze it? Go to stat, quality tools, gauge study, and gauge R&R study crossed. Same thing, instead of create worksheet, uske niche, thoda sa niche cross karke hai, just click on that. Okay, here what you will do is, in the part number select sample, in the operator select operator, and the measurement data select the size in mm. And method of analysis, select X bar R. You can select NO as well. Just select X bar R for this time. Okay. Everybody with me? Okay. Go to option and give the specification limit 1. Okay. You can see a process tolerance, upper minus lower specification. What does it mean? Let's understand this. Very simple. In this scenario, in this case, Let's say this is a data. The mean is around 2.5 mm. Okay. The lower specification limit is 2 mm and upper specification limit is 3 mm. Okay. So this is LSL and USL. So what is the tolerance? 1 mm. 3 minus 2 is equal to 1 mm. That's why we have written 1 mm here. Clear, everybody? Just type yes in the chat box. So within the tolerance, how the measurement system is performing, that also we can check. Okay? So tolerance दे दिया है. Very good. चलिए. So let's click on OK and click on OK. And you will get first this graph. Everybody got this graph? Just type yes in the chat box. Just give me yes. Done? Fantastic. Now let's look at this graph. Now in this graph, this is the very important graph. This is a component of variation graph. Acha, you want me to repeat the steps, Sanchari ji? Okay, so go to stat, quality tools, gauge study, the same where we have created the worksheet, no? Just below that, there is something called cross. Something called crossed. Okay, वो cross को click करिए. Once click on crossed, then in the part name, select sample. Operators में select operator and measurement data में select size in mm. And just select X bar R, method of analysis में. Go to option and select tolerance 1. Upper specification minus lower specification is 1. And click on OK. And click on OK and you will find this graph. Yes, very good. So let's quickly look at this graph. What is basically the learning from this graph? This is the component of variation. Okay. There is gauge R&R, which is basically repeatability plus reproducibility. This plus this is equal to gauge R&R. And the second component is part to part. If you remember, I just made one diagram like this. Okay, ye diagram. This is the same diagram depicted in a different way. Remember, this one is the total variation. Okay, look at, first understand this, okay? Then this one is the measurement variation. I will write MV. And this one is called actual process or part to part variation. Now just try to understand. So measurement system variation and part to part variation becomes the total variation. See, in Six Sigma, basically we reduce the variation. Yes or no? Our main objective is to reduce the variation. Okay. So this part to part variation is coming from, if you see what is this diagram basically? ये diagram कौन सा diagram है? What is this called as? Everybody type in the chat box. Fishbone, right? Now, fishbone has the 6 M's, right? Man, method, material, machine, mother nature, and measurement. Correct? So this measurement variation hai na, this is nothing but that MV, this one. And this is nothing but this gauge R&R. Are you understanding? Whatever variation is induced because of this is this gauge R&R. And remaining are because of man, method, material, machine. Okay, all these are because of this part-to-part variation, and together it is called total variation. How many of you got this? Just type got it in the chat box. Clear hai? Very good. So how beautifully this is designed with the help of statistics, with the help of numbers. In Six Sigma, we only believe in data, right? This is pure data, pure scientific analysis. Okay. Now, according to this, the part to part. So what is expected? What is expected here? Expected here is part to part variation has to be a skyscraper tower, and gauge R&R should be kind of a slum area. Okay. Or ground plus one. That's it. And part to part. What is part to part? Actual process variation. The variation, imagine, so let's imagine this. There are 10 diameter, 10 pens are there, and we are measuring the diameters. Okay. Now there are actual variation in the diameter, actual pure variation in the diameter is there, and there is a variation because of the measurement. So this is quantifying, this system is quantifying what is variation induced because of measurement, and this is that graph. This gauge R&R is that graph, and what is the actual variation because of the part to part, this is called this graph. Okay, so desired state is this part to part bar should be higher and gauge R&R bar should be lower. So in this case, this is absolutely within the control. Okay. Yes. Then after this, then comes the R chart here, R chart and X bar chart. Now this is very, very interesting. R meaning the range chart. Okay. Now the range chart meaning this is Manish, this is Vijay, and this is Yogesh. Okay. So whatever, so they have taken the 10 samples reading, right? Okay. So Manish has taken for first pen, Manish must have taken how many readings? Type in the chat box. Manish must have taken how many readings for the first sample? Everybody? No, for the first sample. First sample. एक ही पेन लिया मनीष ने. वो एक ही पेन का कितनी बार रीडिंग लेगा? 3 बार. 3 times. And there are 10 samples, right? 10 samples are there. So like 1, 2, 3, 4, 5, 6. Similarly, there are 10 samples. But for every sample, Manish will take 3 readings. So in those 3, let's say for example, 10.1, 10.4, and 10.3. For the first sample, Manish has taken these 3 readings. What is the highest reading? 10.4. What is the lowest reading? 10.1. So range is 0.3. And this is called range. So we will plot for the first sample. This is the range dot. Are you clear? Just type yes in the chat box. Just focus on the R chart of the operator, where it will be called as range of the Manish's sample, Manish's readings for the first sample. Similarly, the range for the second sample, third sample, fourth sample, and they are plotted against each and every sample. Are you clear? Just type yes in the chat box. Ye clear hai R chart? So every dot is the range for each and every reading taken for each and every sample. Then Manish will go to the second sample. तो ये हो गया second dot यहाँ पे. यहाँ पे this one will be the second dot. Then it will be the third dot, the fourth dot, fifth dot. So as we go, the range of this, and it is plotted against. Okay. Now only challenge here is with Vijay. Can you see here this data point? Vijay's 9 number data point has got some challenge that needs to be investigated. Why that range has shot up? Is it because of the error in the recording of the data, or some mishap has happened over there? Okay. So this is called a range chart. Clear? Now this is something interesting. X bar chart. X bar chart kya hai? Similarly, now we have taken the 3 readings. Now Manish has taken 3 readings. 10.1, 10.4, 10.3. So we will take the average of that and that will be plotted here. So Manish's first average, this will be the point. Second average, this will be the point. Third average, this will be the point. Fourth average. Clear? This is how the X bar chart is plotted. Are you clear with this? Just type yes in the chat box. So R and X bar chart clear hai? X bar R chart. Now here there is a twist in the tale. The control charts are not basically calculated. Control limits. In our traditional, what you can say, control charts, we have got upper control limit and a lower control limit, right? And every data point has to be within the control limit. That is called as a stable process, correct? Everybody knows this? Stable process, correct? But here it is exactly opposite to that in this gauge R&R. UCL and LCL are calculated differently. Now, what is expected is lot of data should be beyond control limit and very few data should be within control limit. So understand this, within control limit data, this much, in this case, this much, this data is gauge R and R, which represents GRR variation, and the data points which are outside of this are representing part to part variation, which is actual process variation. So ideally, we are expecting less amount of data in the measurement spectrum, which is this band, okay, and more amount of data beyond this band. And we can see this is what exactly is happening in this case. Are you observing this? Just type yes in the chat box. Within the control limit band, there is very less number of data points and more number of data points are beyond control limits, which indicates that part to part variation is making more impact. So it is in line with what we are observing here. यहाँ पे जो observe कर रहे हैं, the same we are observing here. Everybody clear with this? Just type yes in the chat box. Okay, this is not a traditional stability test. This is GRR stability test, a little different. Control limits, formula are different for this. Clear? Very good. So these are the main indicators. Okay, what we have to follow. After that, let's go back to the statistics. Just go to the sessions window. Okay. Go to the sessions window and scroll up. Scroll up. Okay. Now here, the three major contributors we have to basically check. What are the three major contributors? Look at this. The first contributor is this one. Okay. GRR percentage contribution. Okay. Or variance contribution, which is 2.36. So the total variation induced because of GRR is 2.36% and part to part variation is remaining, which is 97.64%. So obviously total GRR is, total GRR has to be less than 10. Okay. Which is the best one. If it is between 10 to 30, still acceptable. And if it is above, if it is greater than 30, then reject. You cannot go ahead with this. Clear? Yes? So conditionally accept. Exactly. Accepted under the conditions. Then the second most important characteristics with the tolerance. What is the percentage with the tolerance percentage? Okay. So tolerance percentage, tolerance मतलब वो जो हम लोग ने एक लिया था ना, upper specification and lower specification. Again, this will be applicable over there. If it is less than 10%, it is best. If it is between 10 to 30, it is conditional acceptable. If it is more than 30, then we have to reject it. And then there is something called number of distinct categories, which is equal to 9. Now, what is NDC or number of distinct categories? Let's say, for example, just for a very simple example, let's say you have a gauge which has got only two parameters. One is called high and one is called low. Okay. So in this case, NDC is equal to 2. Okay. Now, if we have high, medium, and low, my NDC will become 3. If I have extremely high, medium, low, and extremely low, that means my NDC is equal to 5. How many number of distinct categories I have in my gauge, in my scale? That is what NDC is all about. There is a formula to calculate. In this case now, NDC should be equal to or greater than 5. Write this down. NDC should be equal or greater than 5. Okay, if that is the case, then the gauge is accepted. So if these three parameters are meeting, the gauge is accepted. Then only you can collect the data from that gauge. Clear, everybody? Just type yes in the chat box. Yes, exactly. Amritaji, your point is absolutely right. Because the data is part-to-part variation, we are expecting more data points beyond control limits. Okay, because it's a different thing. NDC is number of distinct categories. Up, see, NDC just like it is kind of it is just similar to the least count. Least count पता है आपको पंकज जी? Simple least count, similar to that. Okay, so more the least count, better your gauge, right? आप बहुत ही छोटा सा वेरिएशन आप पकड़ सकते हो. That is what NDC. So if NDC is 5 and above, the gauge is acceptable. If NDC is less than 5, then the gauge is not acceptable. And NDC का formula है. The formula, there is a formula of NDC. If you want, I can write. So NDC can be calculated as, just for your understanding, NDC is calculated is equal to 1.41 into 1.41 into part to part ka sigma. Okay, standard deviation of part to part divided by standard deviation of your total variation. So this is the formula for calculating NDC. If it is greater than 5, it is acceptable. Okay. Clear? Super, super. So this is called GRR, gauge R&R, repeatability and reproducibility. Okay. Now, what we'll do is, let's do one thing. Now, let me just share one more file with you, which is the file of AAA. एक बार attribute agreement analysis भी देख लेते हैं. And once that is done, then we will go for a quick break of 5 to 10 minutes. ठीक है जी? तो ये फाइल डाउनलोड करिए. मीनवाइल जिनको नहीं मिल रहा है फाइल, just go to the same path, measurement system analysis in the black belt, and download that attribute agreement analysis wala file. Once you have opened that, let me know in the chat box. बाकी के फाइलें डिलीट. Opened? Just type yes in the chat box. Now, if you remember, when you have the continuous data, we'll go for GRR. When we have the discrete data, we go for attribute agreement analysis, right? So this is a file. Imagine there is a bank. Now attribute data meaning what? pass, fail, accept, reject. Okay. Now there is a bank and there is a loan application. They are coming. Okay. You can say count data or the discrete data, pass, fail, accept, reject, etc. Okay. So in this case, what they are doing is this is the credit department of a bank and they're disbursing the loan. It's a loan department, a credit. It is credit team. So there are three officers in that: Officer A, Officer B, and Officer C. Okay. Now, similar to this, similar to our gauge R&R, we have taken three officers. Everybody has taken three readings and 10 samples. Now, in this case, sample can be a file, a loan application file. Okay. So imagine this loan application file will go to this loan application file, first of all, will go. Yeah, the first file, this one. I'm talking about this one. So the first file will go to Officer 1. He has rejected the file. And the same file will be given to, in the random fashion to multiple people and we will check. So N meaning no, rejected, and Y meaning yes, accepted. Okay. So they have taken this. Now what we'll do is we will check the repeatability first. First, we'll take the manual repeatability and then the reproducibility. Here, there is only one difference is there is something called truth. Now understand this. There is a challenge here, which is accept or reject. One person can say accept, other person can say reject. But there has to be some standard, right? कुछ तो standard, कुछ benchmark होना चाहिए, and that benchmark is called as truth or the reference value. Exactly, reference point. Okay, so the truth can be the manager of this department, the head of the department, the senior person can be the truth. Okay, so everybody is saying no. If the truth says no, that means everybody is giving the accurate result. Clear? So this is the only change in the gauge R&R in the AAA. Okay, now coming back to how do we do the manual, what you can say, first we will do repeatability. Repeatability, if I repeat it again, the same file given to the same person, if he's giving the same result, it is called repeatability. Okay, so now first we'll do repeatability of Officer A. तो यहां पे focus करिए, this complete region, just focus on this region. Okay, now the first file, he is saying no, no, no. Is he repeatable? Is he repeatable with the first file? Just type yes in the chat box, yes or no in the chat box, everybody. Every time he's saying no, no, no. Is he repeatable? Yes, he is repeatable. Correct? Fantastic. Second file is saying yes, yes, yes. Third file, no, no, no. Yes, 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 no, no, no. So if we see, observe here, he is 100% repeatable. Can you see here? Everybody? Can you observe 100% repeatability here? Just give me yes in the chat box. You open your file and check yourself. Okay, now can you 100% नहीं है क्या repeatable? कहां पे गलती है? The first, Officer A. No, second person nahi, Officer A. First. This is the first one. Just observe the first person, this one. This is the first person. Now this will be a second person. यहाँ पे second person है, and यहाँ पे third person आएगा. ठीक है? Now, okay, let's calculate it for the second person now. What is the repeatability of the second person? Type in the chat box, and then you type repeatability of the third person as well. First person is 100% perfect. What about second person? Type in the chat box. Second person का repeatability कितना है? 90%, because he had just missed the last row. Last row में उन्होंने गलती की है. Yes, yes and no. So he's not repeatable with himself. It is 90%. What about the third person? What is the repeatability of the third person? Type in the chat box. What is the repeatability? 80%. Fantastic. So it is not right in the second row. ये वाले रो में गलती है, and the last, no, second last row में गलती है. Second from the top and second from the bottom, he has made some error. So 80% repeatability. Are you clear? Manually how the repeatability is calculated? 100%, 90%, 80%. Clear hai? Just give me yes in the chat box. Super clear? Very good. Let's find out the reproducibility. Now, what is reproducibility? The same sample, but checked by the various people. Okay? And if they are producing the same result, it's called reproducibility. Okay? So, reproducibility find out karte hain. In the reproducibility, we have to go horizontal, right? So, even if one is mismatching, that is not reproducibility. Clear? Okay? Now, the first one is saying no, 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 no. So everybody is saying no. So this is right. Okay. The second one is yes, yes, yes. But the third officer is saying no. So the second has failed. Third one is again the second officer is saying yes, yes in between. So the second has also failed. The fourth one is all yeses. So this is right. The fifth one is all yeses. This is right. The sixth one is all no's. Yes, this is right. Seventh is right. Eighth is also right. Ninth, there is a problem. And the 10th, there is a problem. So we are getting 60% reproducibility. How many of you got this? Just type yes in the chat box. So I've just checked horizontally each and every row. And out of 10 rows, I found six rows out of 10 absolutely exactly equal. So 60% reproducibility. Clear hai? Repeatability, reproducibility clear ho gaya funda? Just give me yes in the chat box. Super clear? Any doubt here? Now let's do this. Yes. Yes, the reproducibility is. Now, how do you remember this? I'll give you a fantastic trick to remember. Okay. Now, reproducibility. Remember this, huh? Now, how do we reproduce? As a human being, can we reproduce a baby alone? Can we reproduce a baby alone? No. We need a couple, right? A man and a woman, a male and a female, correct? So we need at least two people. So when it comes to reproducibility, we are talking about multiple people here. Are you understanding? Just like yes. So remember like this. Reproducibility is multiple people. Repeatability is the same person repeating the reading again. Clear? Yes? So reproducibility is multiple people, repeatability, the same person giving. So this is how you can remember this. Clear hai? Remember this funda. Okay? Super clear? some memory technique. Very good. Chalo. So let's analyze this with the help of statistics. How do we analyze? Go to stat. Go to quality tools. And attribute agreement analysis. Here it is attribute agreement analysis. Click on that. Now, because the data is in multiple columns, you have to select this one, this option. I repeat again, go to stat, the same option, quality tools. Just below the gate study, we have attribute agreement analysis, AAA, attribute agreement analysis. Just click on that. Select multiple columns. Click on that. Now listen to me very carefully. From on the left hand side, the first column is sample. Okay, usko baad mein select karenge. We need to select all these columns. Okay, all these 9 columns here. All right, from column number C2 to C10. So click on C2, click on shift, C2 shift C10. Everybody, C2 shift, click on shift and C10, and then you just click on select. It will all get selected in this. Okay, I repeat again. Just listen to me again once again. Okay, yeah. When you open, it will look like this. Okay. Instead of attribute column, when do we use this? When this entire data will be in the same column. एक ही column में होगा तो हम लोग ये use करेंगे. But now we have data in multiple columns, right? So click on multiple columns. Click on here, then you will get this data popped up in the left hand side. Select C2 column, shift C10 and click on select. It will get selected. Okay. Number of appraisals, put 3. Number of trials, put 3. Appraisal's name, you can put A, B, and C. Okay. A, B, and C are the names of the people, and the known standard is, click on that and just select the truth. Double click on truth. All right. And let me check, anything else has to be done. I don't think. Yes, I think that's it. Just click on OK. And you will find this graph. Everybody got it? Just type yes in the chat box. मिल गया सबको? Everybody got this? Just type yes. Yes, no. Very good. Let's understand this graph. What is there in this? Within appraisals, which is nothing but repeatability. You remember we calculated 100%, 90%, and 80%. This is what is the repeatability of each and every individual. And with 95% confidence interval, this is what, if this continues, you know, this person will be for a very long time, will be between 98% to maybe 66%, 56%. ये उनका range रहेगा variation का. Okay. Again, there is a formula to calculate. Let's not get into that. This is 100%, 90%, 80%. Now this is what? This is appraisal versus standard. Meaning what? Now when the first one is saying 100%, what does it mean? When the appraisal is saying yes, the standard, the truth is also saying yes. Are you understanding? So how many times it is matching with the appraisal? 100% time it is matching with the appraisal. So this is called accuracy of repeatability. This is called accuracy. This time, the second person is 80% accurate and the third person is also 80% accurate. So the first person for us is the best person among these three. So we can arrange. So what can we do here? Type in the chat box. What can be done? Everybody? We can give the training to person B and C with the help of person A. Okay, because person A is doing a fantastic job. Maybe कोई training program arrange कर सकते हैं इनका. ठीक है? Now let's go back to statistics and we have to check the kappa value. Look at this kappa value here. If you scroll up, there are a lot of statistics. I'll just quickly take you through this. Now, if you really observe this, this is attribute agreement analysis of officer A, officer A trial 1, etc., etc. Now you can see here 10 inspected. Every officer has inspected 10. So you can see repeatability 100%, 90%, 80% here. Okay? 100%, 90%, 80%. Everybody got it from where I'm getting this file, right? Yes. Now, so you were here, let's say, you are here, correct? So just observe this. Observe this area. Okay. This one is for the graph. And this one is called as sessions folder or session window. Okay. And the center wala hai na, wo data ka hai. Wherever the data is placed. Okay. So graph, if you want graph, just click on here, graph will appear. If you want to go the statistical analysis, go to the session window, click here, this one. Just you click here, then you will come to that sessions folder. Okay. Now, so I've just clicked here and I'm coming here. So this is repeatability 100%, 90%, 80%. Correct? Now, just below that, the accuracy we have seen 100%, 80%, 80%. Accuracy of the repeatability, which is with the standard. Correct? And what we are interested is this, the last one. Just scroll at the bottom. we are interested in this value called kappa value. This is all appraisal taken into consideration and the kappa value which is 0 point. In this case, the kappa value is 0.782844. Okay. So for fleece kappa value, fleece kappa, again, it's the name of a statistician. If the fleece kappa value is between 1 to 0.9, it is best. Between 0.9 to 0.7, again, it is acceptable. And 0.7 and below, you need improvement, or you can change the scale. Basically, you need training. You need to coach the people once again. And yeah, so kappa value is a value basically which is calculated. Again, there is a formula to calculate a kappa value. And this kappa value, we have to check whether it is greater than 0.7. If it is greater than 0.7, then the gauge is accepted. And whatever data basically we are collecting from the gauge can be taken for our further analysis. All right, clear everybody? This is called attribute agreement analysis, AAA, AAA. Clear? Just give me yes in the chat box. So if you are very new in the system, this might be a little heavier. But again, this is a black belt hackathon. So some heavier stuff is accepted here. Clear? Just type yes in the chat box. Super. All right. So on this note, what we'll do is we'll just take a quick break of 10 minutes. Okay. And once we are back, we are going to learn about something called transformation. Okay. Data transformation today. Okay. It's going to be a very exciting stuff. So it is 8:35 right now. We'll be back at 8:45 sharp. Okay. Uske baad mein it will be around 45-minute session. Clear? Yes? Just give me yes in the chat box. And once you are back on your seat, just type I am back so that we can start our session again. Okay. So we'll be back at 8:45. Chaliye. Have your coffees, just freshen up and come back. Okay, just type I am back in the chat box so that I can get the confirmation from your side. Everybody. Yes, just type I am back. I'm just waiting for everybody's confirmation. I've got few confirmations, but I'm expecting everybody to confirm that you are back on your seat so that I can start. Super, super. Thank you very much. Okay. Chalo, welcome back to the part two of the today's session. And in this session, we are going to touch upon something called very interesting topic, which is nothing but normality. Now, everybody, uh, before we do the capability, there are two aspects which we do. Okay. And that is called SNC. How many of you remember SNC in the chat box? Just type me in the chat box. SNC. How many of you remember SNC? S, N, and C. Yes. Do you remember SNC? The people who are already green belt certified and about to give the black belt examination. Yes. I hope you remember SNC, correct? What is S? S stands for stability of the data. N stands for normality of the data, which is Anderson-Darling normality test. And C stands for capability of the data, which is the Z value. That 5 sigma, 4 sigma, 3 sigma, that is what the capability is, right? So stability is done. Stability हम लोग कौन से टूल से करते हैं चेक स्टेबिलिटी टाइप इन चैट बॉक्स which tool do we use to check stability type in chat box everybody which tool do we use to check stability of the data think about it type in chat box everybody बोलो स्टेबिलिटी कौन से टूल से चेक करते हैं nobody knows the answer fantastic super the answer is control chart write this down very important okay so control chart if you see it looks like that's what we have done na, just now x bar r chart is what control chart right so UCL LCL and all those stuff ये तो green belt वाला stuff है control chart so what does it tell basically if the data is within control limits that means the process is stable and predictable the behavior is predictable yes or no when the process is within the control that means the behavior of the process is predictable clear then what is normality normality done kahan se karte hum log which tool so there is normality test right Anderson Darling normality test we do normality test okay so this test we'll do right now and then there is something called capability which we do with the help of histogram and specification limit right so stability, normality, and capability, SNC are this is the sequence we have to follow. First you do stability, then you do normality, and then you do capability. All right. So already in the green belt level, we have done stability, normality, capability. But sometimes what happens is the data is coming non-normal. In that case, it is very difficult to, so non-normal meaning skewed distribution. Remember that? I just spoke about skewed distribution data, correct? It is called non-normal distribution where the mean and the mode and the median are different. In the normal distribution, mean, mode, median are very close to each other, are in the center. But in the skewed distribution, where it is non-normal distribution, the mean, mode, median are different. They are differently located. That is called non-normal distribution. Now, in non-normal distribution, you cannot check the process capability directly, because that's what I said. On one side, you have more defect. On other side, you have less defect or no defect. So you cannot basically, properly tell how much defects we are making. That's the reason, this they suggest this, that whenever you come across non-normality, there are ways to handle it. So first, let's identify a non-normal data. Okay, I'm just sharing a file with you guys about non-normal data. Just open this file. The name of the file is log transformation. Let's open this file. And first we will check the normality of this data. Okay. So how do we check normality of the data? I'll show you. Once you open this file, let me know in the chat box that file opened. Log transform. The name of the file is log transformation. First, we'll check the normality, and then we will see what needs to be done with this. Super. Now let's look at the data. So they have got a test data basically. Let's say blood sample is coming, and with there are various tests, and they have collected the data of various tests basically. And they just want to check whether it is normal distributed data, doesn't seem like, or so they just want to check this data called time data. Is it normally distributed or not? So how do we find out this? Go to stat, go to basic statistics, and normality test. Okay, I'll repeat again. Stat, basic statistics, normality test. I'll just stop sharing once again. Go to stat, basic statistics, normality test. All right. अच्छा, आपको फाइल नहीं मिला? तो फाइल is available. Let me show you the file. Yeah, let me show you the file in the black belt. So if you see this one, okay, if you see the normality and transfer, just below the measurement system analysis, there is a normality. So I'm just going step by step here. Normality and transformation, right? So here there is a file called transformation Minitab file. Just click on that file. Just click on start, and you will find this. Okay, this one. Just download this file, transformation Minitab file. Clear? Okay, recording is not on, is it? Oh, great. अरे कब से बंद था recording? Is it on now? Yes. Superb. I hope the earlier part is recorded. Okay, let me. So what we are doing here is we are talking about a normality test. So let's open the file. Okay, now what we'll do is go to stat, basic statistics, normality test. Click on that. Select the variable as time. Just double click on time. That is the variable I want to check. And click OK. And this file will appear. This graph will appear. Everybody got this? Just type yes in the chat box. सबको मिला है ये? Just give me yes in the chat box. Just give me the confirmation. Super. Now, what is this? On the x-axis, it is time. On the y-axis, it is percentile. How many of you remember percentile? Quartile, percentile. How many of you remember that? Just type yes in the chat box if you remember. Very good. Let's not get it's a green belt stuff. हम लोग green belt में वो cover करते हैं. Yes. So what is this basically? Yes, 100th part. Correct. Exactly. Now, so this is the line of significance. The red line is called line of significance. And whenever you find similar kind of data, which is not very much close to the line of significance, and they are away from this kind of data you are seeing, it is away from the line of significance. Here also, it is away from the line of significance. That is an indication that the data is not normal distributed. Okay. If the data is normal distributed, generally the graph will look like this. Very closely bound data like this. Okay. So this is the first indication, but the most important indication is the p-value. If the p-value is greater than 0.05, then the data is normal. In this case, the p-value is less than 0.005. Can you understand this? Okay, so that is the reason this is called as non-normal distribution. Clear everybody? Just type yes in the chat box. Clear hai? Clear? So this is non-normal distribution. Whenever the p-value is less than 0.05, in the green belt level, we check all the normal distributions are there, and then we'll go directly for the process capability. But if you come across a non-normal distribution, how do we handle this? The first point what you need to do is what we need to do is identify and remove outliers. Identify and remove the outliers from the data. That's the first thing what you need to do. Second is increase the sample size. Why? Why do we increase the sample size? Because of CLT, central limit theorem. Remember, in the beginning, we have seen the central limit theorem. As we increase the sample size, the data will normally take the normal distribution shape. Remember that? Just type yes in the chat box if you remember that. Now, whenever you come across non-normal distribution, remove the outlier. That is the first point. Second, increase the sample size just to take the normal distribution shape. Even if it does not, getting the normal distribution, then we go for transformation. The third step is called transformation. Step number 3, it's called transformation. Now we have to transform the data, and that is how we have to do it. So how do we transform the data? All right. So we need to go to stat, control charts, box, Cox transformation. Just follow this path. Everybody go to stat, control charts, box, Cox transformation. Stat, control chart, box, Cox transformation. Okay. Once you click on that, this window will appear. All observations are in one column. Yes, our all observations are in one column, which is the column called time. Okay. And subgroup size is, you can just type 1. Subgroup size is 1. Okay. And say okay. I repeat again, go to stat, control chart, Box-Cox transformation. All right. Once click on that, there will be time. You need to just select a time column. Subgroup size is 1. Subgroup is nothing but, is it an individual sample or you are taking a group of samples? Here we have taken individual time of every test, right? So it is subgroup number 1. We have taken only one sample at a time. So subgroup is 1 and click on OK and you will find this. Everybody got this? Just type yes in the chat box. सबको मिला ये ग्राफ? Super. Now this is called as Box-Cox plot. Okay. Now what does it say? This is a lambda value. Just like alpha, beta, theta, gamma, delta, lambda is also Greek letter. What we're interested in this rounded value, which is called 0.00. So lambda in this case is 0.00. So it is 0 basically. Now in your black belt curriculum, in the data transformation section, we have given you a reference table. Okay. I'm just showing you that reference table quickly. So the lambda value is 0. In that case, what you need to do? So I'm just going back to the reference table here. So this is my reference table. Look at this. Whenever my lambda value, so this is the lambda value. Let's make it white. Okay. This is what kind of transformation we have to do. Okay. For example, when the lambda value is 0, you can see the log transformation, log y, meaning whatever data is there, we need to take the log value of that. Whatever data is there, we need to take the log value. Now, what is log value? How many of you remember log table during your schools and college days? Log table हम लोग use करते थे. Generally, science and maths में use करते थे. Remember? How many of you remember log tables? Just type me in the chat box. Some of you must be remembering, right? But you would have forgotten what is that log, correct? So let me explain you what is log. Let's say 10 raised to 1 is equal to 10. Correct? So log of 10 is equal to 1. Understand this. 10 raised to 2 is equal to 100. So the log of 100 is equal to 2. Just try to understand this. 10 raised to cube, which is 10 raised to 3, is equal to 1000. So log of 1000 is equal to 3. Are you understanding this? So these are called log numbers. So if this is your number, which is 10, 100 and 1000, instead of this number, we will take the log number. This is a log number. So 10 ka log number is 1, 100 ka log number is 2, 1000 ka log number is 3, and all the numbers in between. Are you clear with this? This is called a log values. So what software is suggesting, that you need to transform the actual values into log values, and then you need to actually check the process capability of this. Clear? Yahan tak clear hai? Just type yes in the chat box. So what we have done, we have gone through Box-Cox transformation, put the data, check the lambda value. We have come to this table. Lambda 0 is equal to log. Now understand this. If you focus here, if lambda is 0, go to log value. If lambda is 0.5, understand this, then you have to take the square root of that. You have to take the square root of the value. Okay. If lambda is equal to 1, you need not to do any transformation. Okay. If lambda is equal to 2, then you have to take the squares of the value. Similarly, on the line downside, you can see if lambda is minus 0.5, then you have to take the reciprocal square root, which is 1 divided by square root of the value. And if lambda is minus 1, this is reciprocal of that value, which is, if it is 1, then 1 divided by 1. If it is 10, then 1 divided by 10. Like that. It's got a reciprocal value. Clear? And this table is, and you can extend this table. If lambda is minus 2, then 1 divided by reciprocal square. When lambda is minus 3, 1 divided by reciprocal cube. If lambda is minus 4, 1 divided by reciprocal 4. Reciprocal, what you can say, raised to 4. Are you clear? This is how you can extend this. If lambda is 3, it is the cube value. When lambda is 4, it is raised to y raised to 4. Like this, you can extend it. So lambda value generally is between 5 to minus 5, plus 5 to minus 5. Remember this, lambda value is always between plus 5 to minus 5. And you can find out the transformation associated with that. Clear, everybody? Just type yes in the chat box. So right now it is 0. So we are going to do a log transformation. Now, how do we use the log transformation? Let's go to the data. I'm just opening the data once again. Where is the data? Yes. So let's go back to the data, open the data like this. Okay. Now, let's give this column C5 the value log, log. Just type log in the C5, which is the empty column there. The fifth column C5, just give the name log there. Okay. Now, just look at this. Go to calc. Calc meaning calculator. Click on the calculator. Okay. Just follow this step. First, come to the data. Data पे कैसे आते हैं? Just click here. You will come to the data directly. Okay. Worksheet folder or Control Alt Delete. Control Alt D, not delete. Control Alt D. Not delete. Control Alt D. If you click on Control Alt D, you will come to the data, or you can just click here. You will come to this data. Now, in the C5, just select, just give a title log in the column. Now come to the calculator. Select calculator here. This will appear. Now store result in the variable log. Store the result in variable log. कौन से कॉलम में स्टोर करना है रिजल्ट को? लॉग में करना है. What is the expression? Now here to select the expression, first select, just put a drop down and come to a logarithm. Can you see here? यहां पे एक ड्रॉप डाउन है ऑल फंक्शंस में, उसमें हम लोग सिलेक्ट करेंगे लॉगैरिथम. ओके, एंड इन द लॉगैरिथम वी विल सिलेक्ट log base 10. Just double click on that. Log base 10 को double click करना है. It will get selected over there in expression column. Okay, मैं फिर से एक बार repeat करता हूं. Just listen to me very carefully. Go to calc, which is calculator. Open the calculator. Store the result in log. Double click on log. Okay, functions, all functions. Just drop down this and select logarithm. Log base 10 को double click करना है. And in the number, so there will be log 10 in the column. Now you have to select the time column here. Okay, time. Just double click on time. So it will be log 10 in bracket time. Everybody with me till now? Just type yes in the chat box. No, it's base 10 log. Okay. We are going to take the base 10 log. Super. Natural log में वो exponential ले लेता है. We are going to take base 10. ठीक है? And click on OK. Now the moment we have done OK, for the corresponding time value, this is a log value we have created. Understand this. Okay. For example, if I scroll down, look at the log value of 100, you will find, the time value is 100, the log value is 2. Remember that? 10 raised to square is equal to 100, right? So log of 100 is equal to 2. So it is, you can see here. Clear, everybody? Just type yes in the chat box. So now this is the data. Now we have to do the process capability analysis. Now, right now, let's do the LSL and USL. Okay. यहाँ पे LSL and USL हमें find out करना है. First of all, decide करना है. So we will just take some, some random LSL and USL. Let me check कौन सा LSL, USL हम लोग ले सकते हैं. So we will take 400 and on the lower side we will take 50. Okay. So look at this. So what we will do here is we will take So this is your distribution, correct? There is a lower specification, there is upper specification. So lower specification limit and upper specification limit, correct? So lower specification, I'm just randomly selecting 50 and upper specification is 400. So we have to convert that. These are the actual numbers, right? These are the actual values. But we have to select the log values for this. So the log values for the 50, you can see here. Here you can see here 1.69897. Can somebody write this down? 1.69897. This is the log value of 50 and log value of 400 is this. Okay. See, मैंने यहां से लिया है 50 का नीचे से and 400 का log value है ये this one. I can find 400 here and this is the log value of 400 which is 2.60206. Everybody? Okay. Can you just type in the chat box so that we can take the reference from there? Click है? लिख लिया सबने? Yeah, दोनों का भी वैल्यू लिख लिया. Fantastic. Madhu ji, thank you very much. Okay, now what we'll do? We'll do the process capability analysis. Okay. The same process, go to stat, basic statistics. No, not basic statistics. Quality tools, capability analysis, normal. Now because, okay. Now एक बार चेक करते हैं ये डेटा नॉर्मल डिस्ट्रीब्यूटेड है क्या? ओके, एक बार चेक कर लेते हैं ये डेटा नॉर्मल डिस्ट्रीब्यूटेड आया है क्या? इट शुड बी वेरी क्लोज टू नॉर्मल डिस्ट्रीब्यूटेड. एक बार चेक कर लेते हैं. ओके. Log data. Yes. Can you see here? Now the data is p-value is 0.299 which is greater than 0.05. So it is normal distributed. Clear है? तो ये normal distributed आ चुका है. Now we will do, go to stat, quality tools, capability analysis, normal. Okay. Now in the single column, select the log data. Subgroup size is 1. Lower specification limit. यहाँ पे हमें log data को लिखना है which is 1.69897 and the upper specification is 400 which is the log value is 2.60206. Clear everybody? यहां तक हो गया? Once you put the lower and upper specification, go to option and select benchmark Z. Just select the benchmark Z here and click on OK and click on OK. Wow, look at this. So here you can see our benchmark Z is 0.89, which is longer, what you can say, long-term process capability, and short-term is also 0.90, which is very close. So right now we can say that our process is 0.9 sigma process. This is a Z bench value. So our process is 0.9 sigma. 1 sigma se bhi niche hai. So we need to improve our process. Are you clear with this? Just type yes in the chat box. Super clear? Everybody? So this is how you need to transform the data and do the process capability analysis. Okay. Now, last couple of weeks back, we had taken a live session on one of the Saturdays. I don't exactly remember the date, but we have taken. Okay. How do we calculate each and every data in this, whatever the graph is showing, na, each and every calculation, we did it manually. And I must recommend that session to be attended by everybody. You know, uska recording hai masterclass archive mein. All right, let me just show you which recording basically I am referring to here. Okay. एक बार मुझे, yeah, just give me a second. So masterclass archive में there is a So whenever we have the live session on Saturdays and Mondays, if we miss the live session, go to Masterclass Archive and check the recording. Now, what I'm talking about is this. Okay, I'm just opening the Masterclass Archive and yes. So on 18th of January, I'm just sharing this with you guys. This is going to be a mind-blowing experience for you. Okay, just check this video. 18th of January wala process capability statistics explain. Process capability statistics explain 18th of January 2025. Okay, just need to check this video in the masterclass archive. Everybody clear with this? In this particular session, we covered basically how each and every value of that table, no, whatever graph we have seen, and there are a lot of numbers around that. Each and every value, what is sigma value, what is CPK, PPK, CPM, what is how do you calculate PPM value, part per millions, okay? All these things within PPM, all these things, overall PPM, within PPM, everything is manually calculated with a formula. Okay, it's going to be a fantastic experience for you. Clear? So my recommendation is please go through this session. I'm just giving you the link of the session right away. Okay, this is a link. This is the link for that session, particular session. मैं आपके चैट में डाल रहा हूं, ठीक है? So this is the recording of that. और मैं चैट में इसका लिंक डाल रहा हूं, तो यू कैन जस्ट क्लिक ऑन द लिंक एंड डायरेक्टली गो टू द सेशन. अभी नहीं, बाद में, ठीक है ना? क्लियर एवरीबॉडी? जस्ट टाइप यस इन द चैट बॉक्स. सुपर क्लियर विद दिस? अमेजिंग. हेवी हो गया थोड़ा सा. थोड़ा सा हेवी हो गया ना? या सो टुडे लेट्स रिवाइज वॉट एवर वी हैव कवर्ड टुडे. क्या क्या कवर किया हम लोगों ने टुडे? कैन वी जस्ट रिवाइज क्विकली? Can you just revise quickly whatever we have covered today? Type in the chat box quickly. Randomly open your notes. Whatever we have covered in the beginning. First, how to generate the data in Minitab. Yes, data generation. Fantastic. First, we selected data generation. Then, we have seen central limit theorem. So, then created histograms. And through those 3 histograms, we got central limit theorem. CLT. हम लोगों ने सीखा. Correct? Yeah, CLT. After that, we have seen measurement system analysis. We went to gauge R&R and then AAA. So gauge R&R mein, we have seen the basics of gauge R&R. Then we created the worksheet of gauge R&R. Then after worksheet creation, we understood the analysis of gauge R&R. And we have seen all the statistics behind gauge R&R. Then we have seen attribute agreement analysis. What is the difference between attribute agreement analysis and gauge R&R? Gauge R&R is for the continuous data. Attribute agreement analysis is for the discrete data. Correct? So we have seen all these attribute agreement analysis, and we have seen the kappa value, Fleece kappa value, right? In gauge R&R, we have seen the percentage GRR score, the graph, NDC, all the stuff we have covered today. Fantastic. And then after that, we have seen SNC, stability, normality, and capability. Correct? These are the 3 steps we have to follow before we cover the process capability. Correct? First, we need to check the stability, then normality, then capability. So, stability we have already covered in the green belt, which is X bar, R chart, I chart, etc. Then we have covered normality test today, where Anderson-Darling normality test, if the p-value is greater than 0.05, then the data is normal. But if it is not normal, then we have to use first. What are the steps we have to complete to make the data normal? First, remove the outliers of the data. Second, first remove the outliers. Second, increase the sample size. Increase the sample size, because according to CLT, as we increase the sample size, then we can get the normal distribution. If both of these systems fail, then we go for the transformation. Then we have seen the Box-Cox transformation. Okay, stat control chart, Box-Cox transformation. Select the data, and it will give you a lambda value, right? Lambda value it will give. Once lambda value is given, then, once the lambda value is given, then you can select from which lambda value, what will be the transformation. Okay, so I've just shown you that table. Lambda 1 is equal to, lambda 0 is equal to log transformation. Lambda 1 is equal to no transformation required. Correct? That table I have shown you, which is already given in your black belt content. Correct? So in this case, lambda was 0. So we have to go for log transformation. In the log transformation, we select one column and gave the name log. We went to the calculator, converted that entire data into log data. Correct? And then we have done the process capability analysis. And that is how the transform data was. And we checked the normality as well. Okay, so normality was improved. Correct? Yes or no? Earlier it was 0.005. The p-value was. Later it was 0.299. So after transformation, the normality was improved. And after that improvement, we did the process capability analysis, and we found that the data is our process is 0.9 sigma process. Okay, this is how we have to calculate this. Okay, so what we'll do, because it is a heavier session, today we will stop here. Tomorrow we will connect again at the 7 p.m. Okay, and go ahead. Tomorrow we are going to cover the advanced hypothesis testing like pair t-test, ANOVA, chi-square test, F-ratio test. There's so many other tests, and how to calculate p-value. That's something which we are going to calculate as well. Okay, so stay tuned, keep learning, keep growing, and we'll connect again at 7 p.m. tomorrow. All right. Thank you very much. Take care. Keep learning, keep growing. This is Dinesh Patil.